So here we're being asked to use the properties of the definite integral to express the definite integral of this function over the interval -2 to 1 as the sum of three different integrals, right? So they're giving us a and b. They're giving us f of x, of course. And so we can set that up. We can say that we're going to go from -2 to 1 of -3x cubed plus 2x plus 2 dx. All right, and we want to convert this into three definite integrals. So first of all, we can use the sum and difference property, right, to say that, okay, well, it's going to be -2 to 1, and it's going to be -3x cubed dx plus integral from -2 to 1 of 2x dx plus the integral from -2 to 1 of 2 dx. Right, so I just took each of these components and took the integral of each of those separately, right? The integral of a sum is equal to the sum of its integrals. And so now what we could do, and this is actually already satisfied the requirements, but let's just break this up even more. So let's bring these constants out to the front. This one's okay because there's no other value there, so we'll just leave that there. But we'll go -3 here in front, -2 to 1 of x cubed dx plus 2 times the integral from -2 to 1 of x dx plus the integral from -2 to 1 of 2 dx. All right, and so that's our answer. That's the sum of, we made that into a sum of three definite integrals. All right, so you try this one out. So make this into this from 1 to 3 as a sum of four different integrals. Good. If you got that, if you got the integral from 1 to 3 of 6 times the integral from 1 to 3 of x cubed dx minus 4 times the integral from 1 to 3 of x squared dx plus 2 times the integral from 1 to 3 of x dx minus the integral from 1 to 3 of 3 dx. Then good job. All right, 1, 2, 3, 4. All right, in this one, we know that from 0 to 8, the derivative of f of x, or excuse me, the integral of f of x is 10. We know from 0 to 5 it's 5, and we want to find the value from 8 to 5, or 5 to 8, I should say, of f of x, right? And so we know that this is true. Like, we know that the integral from a to b of f of x dx is equal to the integral from a to some other number that's in between a and b, f of x dx, plus the integral from c to b of f of x dx. Okay, so here we have that going on. So we just need to figure out what the bigger part of the interval is, or what the, what's on the left side here is from the lowest endpoint to the highest endpoint. And the lowest is 0, right? And the highest is 8. So this is the one that we want to put on the left. So I know that the integral from 0 to 8 of f of x dx must equal the integral from 0 to 5, right, which is this one, f of x dx, plus, let's pick up where we left off at the 5 and start from 5 to, and that's what this one is, 5 to 8 f of x dx. So now let's plug in what we know. We know that the integral from 0 to 8 of f of x is 10, so I can put a 10 there, right? And then we know the integral from 0 to 5 is 5. So I can put a 5 here, right? And then this is the one that we're trying to find, right? We don't know what this is. So this one we're just going to leave as it is, okay? And so we're just going to put plus the integral from 5 to 8 of f of x dx. All right, and so now we're trying to solve for this, right? This is what we're trying to find. So we're just going to subtract 5 from both sides. And we can see that our answer, the integral from 5 to 8 of f of x dx, is just 10 minus 5, which is 5. So that's our answer for this. All right, so it's actually just a little bit of algebra, right? Solving for an unknown value. This time our unknown value happens to be a whole integral, right? But we use the properties that we know with the information that we're given to set up this equation of integrals, and then we're able to solve for the integral that we're looking for, kind of in an indirect type of way. All right, so go ahead and do a similar thing with this one. So with this time we know integral from 1 to 5, from 2 to 5, and we're trying to find the integral from 1 to 2. All right, so go ahead and set up the equation. All right, if you got this, great job. So we get this, the lowest of the lows to the highest of highs, right? Then we start from the low, go somewhere in between, start at that place in between, and go to the end, right? And so now go ahead and plug in what we know about those. All right, good. So -3 equals the integral from 1 to 2 of f of x dx plus 4. So we know that this equals -3. And then we know that this equals positive 4, right? And so now go ahead and solve and find the value of that integral that we're looking for. All right, nice. If you got -7, good job.